Viewers, welcome to Big Boy Physics. And today in this video I'll be taking up a problem which is a mixture of modern physics and thermodynamics and involves a little bit of concept of statistical mechanics. So if you have gone through my previous videos, you may have known about that if we need to find a probability that a particle possesses some energy E, then we say that a probability is proportional to e to the power minus e by kbt. Now, if you want to find a probability that the particle possesses energy between E to dE plus dE, then the probability dP is given as A times e to the minus e by kbt into dE, where A is called the normalization constant. Okay, so basically this gives the probability that the how many amount, if you are given a bulk of particles, then what is the probability that if you pick up a particle among them, you will yield that the particle possesses energy between E to E plus dE. Now, what will be the number of particles possessing it? So the Dn would be A times n naught, where n naught is the total number of particles, e to the minus e by kbt dE. So this will give the number of particles. The above expression basically is the fraction of particle among the bulk. Okay. And one thing to say that StatMech is generally applied on bulk, but in this case we can apply for small particles also, because we don't know what will be the state of the particle. That is why we are asked to find all the part 1, 2, 3, 4. Okay, so let's get started. The question says spin system. Let us consider a system of n independent magnetic dipoles in a magnetic field B and temperature T. Our goal is to determine some properties of the system using statistical physics. It is known that energy of a single spin system is E, which is equal to epsilon times m, where m is given as plus minus half and E is given as a alpha b. Okay. Now you have to tell me the probability that the spin is an excited spin, that is have positive energy. We have to find the probability that the spin has positive energy, that is m is equal to plus half. Okay. So suppose you have a dipole and we need to determine that whether it has a positive spin or a negative spin. So what is the probability that it has a positive spin? It will be e to the power minus epsilon m by kbt. Putting the value of m, it will be e to the power minus e by 2 kbt, and probability it has downward spin is equals to e to the power plus e by 2 kbt. So like that we do in case of finding the normalization constant, is that integral dp is equals to 1, and from here a will come out to be e to the minus e by kbt de, yeah, 1 by e to the minus e by kbt de integral. So same thing, but instead of using integral we'll be using summation here. So in this case let the normalization constant be a, right? So a times e to the power minus epsilon by 2 kbt plus and plus e to the power minus plus epsilon by 2 kbt is equal to 1. So finally a will come out to be 1 by e to the power minus epsilon by 2 kbt plus e to the power plus epsilon by 2 kbt. But already it's mentioned that epsilon to take as alpha b. E is equals to alpha b. So basically this will come out to be the normalization constant. Okay. Now what is the probability of positive direction spin? It will come out to be e to the minus epsilon by 2 kbt by the normalized into the normalization constant, and they will get it to be e to the minus epsilon by 2 kbt plus the rest other factors. Hope you get the first question. So our first part is done. Second part says that what is the average value of the total energy of the spin system as a function of b and t. Now what is the number of particles having positive spin? Just multiply with n, and number of particles with negative spin, just multiply with n again. but in this case the numerator will contain plus E by 2 kBt. Okay, and rest of the factors. Now, what is the energy of the particles possessing a positive spin? It will be just multiplying with epsilon m, that is epsilon by 2. What is the number of what is the energy of the particles possessing negative spin? It just multiply with minus E by 2, and he will finally end up with something like minus Ne by 2 e to a minus E by 2 kBt plus e to a plus epsilon by 2 kBt. Okay, and the numerator will be e to a plus epsilon by 2 kBt minus e to a minus epsilon by 2 kBt. So basically the second part is also done, and you know that this numerator upon denominator, this whole factor is written as hyperbolic tan h hyperbolic function. This is called a hyperbolic function e by 2 kBt, and this denominator e to a minus epsilon by 2 kBt plus e to a plus epsilon by 2 kBt by 2 is given as cos h e by 2 kBt. Basically hyperbolic functions, right? So this will come out to be es. Then the third question says that at high temperature approximate T much greater than alpha b m by k. So basically you have to take T to be so high that the above numerator factors, that is alpha b by k, is very negligible, and here k actually represents the Boltzmann constant. Okay, and m is the spin quantization, means basically the m is plus minus half, all those. You have to simplify the expression es. Will you know that for small alpha, e to the alpha is written as 1 plus alpha? Basically, we will be applying the same. You will end up es is equals to um, minus ne by 2. Denominator will come out to be 2. Numerator will come out 2 into e by 2 kBt. And simplifying the expression, you will get minus ne square by 4 kBt. Right? So this will be my answer. Basically, the average energy of the system will come out to be minus Ne square by 4 kBt. T is the temperature of the system. So next, then it's asking to find the specific heat capacity of the spin system. No, it's if it's had asked about specific heat capacity, then it would be 1 by mass times all those. But here it's asking about heat capacity rather. Heat capacity is given as du by dt, and specific heat capacity is given as sys and S is given as du by mdt. Whereas molar heat capacity C molar is given as du by ndt, where n is n by na, where n is the number of molecules. So heat capacity is given as minus ne square by 4 kb d by dt of 1 by t, which will come out to be minus plus ne square by 4 kb t square, and that's the answer. So we have solved the problem. Hope you enjoyed it and learned something new. Thank you and have a nice day.